Instrumental insemination of queen bees. Throughout the history of apiculture, beekeepers have endeavoured to control the quality of their stocks. As with other domestic animals, over the past few decades, selection has achieved remarkable results. Selection criteria include abundant honey yield, gentleness, as well as the tendency to stay put on the comb, low swarming disposition, and good resistance to disease. Maintenance of pure strains depends on controlled mating of queens and drones. This is only possible in remote bee-free areas, for example on islands, because drones can fly up to 7 and queens up to 5 kilometers before mating in flight. For mating, selected drone stocks are taken to so-called island queen mating apiaries. The color-coded nucleus hives accommodate young queens with their colonies. These virgin queens are sent to the mating station by beekeepers during June and July. On arrival, the single-comb travelling boxes have to be checked that they are free of drones and have a good food supply. They are then placed in the hive. The entrance must always be kept free. After mating, the queen returns to her nuclear colony. Not every queen mating station is fortunately free of unwanted drones. That is why instrumental insemination of queens is gaining in importance. It is independent of weather conditions, produces better breeding results, and also permits the use of drones from various different stocks. It is essential for the donors to be fully mature. The readiness of a stock of bees to rear and feed drones depends largely on outside influences such as weather and available food supplies. An empty comb with drone cells is placed in the drone colony about 50 days prior to the proposed insemination date. As required, stimulation is provided by feeding or dequeening it. The development of the drones from egg to hatching takes 24 days. About 2,000 drone cells occupy one side of a drone comb like this. 2 more weeks pass between hatching and the achievement of sexual maturity. Warmth and abundant food are essential during this period. To determine the age of the drones at any time, colour marking immediately after hatching has proved to be a very useful procedure. The drones can then forage freely until needed. The reared queens are introduced into mating colonies. Multi-comb cages made of foamed plastic are of proven value here. After 6 days, the queen is sexually mature. She is marked in the appropriate color for the year. On the day before insemination, the queen is caged so that she can be later narcotized with CO2 in the laboratory. This treatment takes about 5 minutes and it helps to accelerate the onset of egg laying. Until she is inseminated, the queen is returned to her nuclear colony. Hygiene is essential in the insemination laboratory. All glass and metallic instruments are autoclaved daily. In preparation for semen collection, a semen diluent, for example saline solution or, as here, tris buffer, is drawn up. The liquid is sterilized by microfiltration. The pore diameter of the membrane is 0.2 microns. Now the insemination syringe is filled with the buffer solution. Bubbles of air are carefully removed. The syringe is assembled and the column of liquid advanced to the front, save for a small bubble of air at the tip of the glass tube. Then the syringe is mounted on the insemination apparatus. Drones which have been reared in cages by workers are used as semen donors. Rolling and pressure on the thorax and abdomen effect the first phase of eversion of the copulative organ. Further pressure results in complete eversion and ejaculation. Mature sperm is cream-colored and marbled in appearance. As here, it often covers the white mucus plug of the endophallus. Using the glass tip of the insemination syringe, merely touch the surface of the semen covering. In aspirating the sperm, none of the mucus should be allowed to penetrate into the syringe, thus preventing the cannule from becoming obstructed by a mucus plug. Similar to the natural mating process, the semen of several drones is aspirated in portions. A minimum of 8 microliters are required for insemination. This corresponds to the quantity of semen donated by 8 to 10 mature drones. If necessary, the tip of the cannule is cleaned off with a sterile swab. A drop of diluent closes the capillary to prevent the semen from desiccation. Now the syringe is ready for insemination. The term sperm homogenization implies that the semen of, say, several hundred drones is blended to increase genetic diversity. To do this, the sperm content of several capillaries is diluted with tris buffer solution in a proportion of 12:1. Every operation must be carried out under ultra-clean conditions because a single contaminated portion would adulterate the entire batch of semen and endanger all the queens of an insemination series. Because of the high effort involved, this technique should only be applied to large-scale breeding programs. A pipette is used to mix the suspension thoroughly and fill it into a special centrifuging tube. Any rotary centrifuge is suitable for centrifugation. After a 10 to 15 minute run at 1000 G, the sperm are deposited at the lower end of the tube. The clear supernatant is removed and the plastic tube is cut off on a level with the surface of the sperm. The insemination syringe is then filled with the homogenized semen. A queen, who was treated with CO2 on the previous day, is placed headfirst into the retaining tube. Then, the queen holder is fixed to the block on the instrument. A whiff of CO2 helps to immobilize the queen. To control the dose of gas, it flows through a washing flask. The ventral hook, left, engages behind the ventral plate of the last segment. The dorsal or sting hook, in this case a perforated hook, exposes the sting chamber. The sting lancets and epidermal folds are now visible. The vaginal orifice is recognizable as a wrinkled bulge in the middle. The syringe is adjusted in the direction of the vaginal bulge and the droplet of diluent removed. The vaginal orifice is only exposed in techniques which lift up the sting apparatus. The syringe can therefore be inserted without the use of a vaginal probe, and the semen is injected directly. This concludes the insemination procedure. The syringe and the hooks are removed. The still narcotized queen is released from the holder. Clipping one wing prevents her swarming later on, but it is nonetheless essential to cover the entrance of the mating cage with an excluder as well. Bee candy seals the cage and the queen is returned to her hive. The more favorable the brooding and temperature conditions are for the queen, the sooner she will begin to lay eggs. The egg is clearly recognizable as a small whitish rod close to the base of the cell. Capped worker brood confirms the success of insemination. The store of semen in her spermatheca will last for the queen's entire life. The young queens are introduced into wintering colonies. They are in no way inferior to freely mated queens, either in performance or longevity. Instrumental insemination is now about 90% effective. This is in excess of the results achieved by natural service at mating stations. For this reason, the technique will become increasingly important to practical apiculture in the years to come.